Hello, this is Mr. Wynn, and this video is solving quadratics. So a quadratic equation can be solved by four methods. The first one's graphing. It's not the greatest because it can't find the exact solutions as a sketch, but it is good for telling us how many answers there are. The second method is factoring. That is the fastest and actually the number one method for solving. It only works if the problem is factorable, which 90% of our problems are. The third method is a quadratic formula, and this is our backup plan for solving. It's not fast or slow, it's right in the middle, but works for every single problem. If a problem is unfactorable or it takes you more than a minute, you should try quadratic formula. And the last option is completing the square. It's the slowest and very complicated, but it does work for every problem. And note, a problem is not factorable if the answers are imaginary, with I, no real solutions, or when the answers are irrational. So the first one, factoring, is the best and fastest way to solve any problem due to what we call the zero product property. The zero product property says if there's two or more things that multiply to equal 0, then one of these things has to be 0. For example, A times B equals 0, either A is 0 and B could be whatever it wants, like A could be 0, B could be a million, 0 times a million is 0. Or maybe reverse that, B is 0 and A could be whatever it wants. If A is -3 and B is 0, -3 times 0 is 0. A more common example would be this: if 3x times x minus 2 equals 0, then either this first thing equals 0, and the parentheses can be whatever it wants, or the second thing equals 0 and the first thing can be whatever it wants. Alright, so I'm going to solve those. If I divide both sides by 3, I get x equals 0. That's one answer. If I add 2 over here, I get my second answer. If I plug either of those in, you'll see that it'll be 0 equals 0. So when I plug in 0, 3 times 0 is 0. 0 minus 2 is -2. That's what equals 0. Well, 0 times -2 is 0. 0 equals 0, that's true. So I solved that. If I try the other one, positive 2. 3 times positive 2 is 6. Parentheses 2 minus 2 is 0. So it's equals 0. 6 times 0 is 0. 0 equals 0. That's true. So we found the two answers. So it's really easy. It's a single multiplication problem that's equal to 0. So here are the steps. Make sure 0 is alone on one side. You might move things around, and again, that's called standard form. Then you factor like normal. Always do GCF first, then count the number of terms. 2 terms says the difference of squares, the square root formula. 3 terms, guess and check. 4 more terms, do grouping. And the last thing is set each factor equal to 0 and solve. And there should always be at least 2 equations. Alright, so this bottom right, here's the problem. It does not take much space. Again, it's really short and fast. Solve by factoring. It is in standard form. There's 0 on one side. I'm going to do GCF. I notice that they're all even. I can take out 2. What's left over is 2x squared minus 5x minus 12 equals 0. After I GCF, I count. There's 3 terms. That means I should do guess and check. Don't forget the GCF out there. When I guess this, I should guess 2x and 1x for the left side. And for 12, it's 3 and 4. If I do 3 and 4, that gives me 8x for the O, 3x for the I. Can 8 and 3 make 5? Yes. I need a -5, so the 8 is negative, and the 3 is positive. Check the sign of L. Positive times negative is negative. We're good. Since we're fully factored, final step, step 3, is set every factor, every parentheses pretty much equal to 0. So this first one, 2x plus 3 equals 0. And the second one, x minus 4 equals 0. Now, you can't really do the 2 equals 0 because there's no letter there. It's just a constant, but if it has a letter, you must set it equals 0. I saw the first one by subtracting 3 and then dividing by 2. So x equals -3/2. So I found one answer. The next one, I'm going to solve it by adding 4. So x equals 4. I found my second answer. So this problem had 2 answers. Now, there's multiple answers. You should make it set notation. So you should say x equals the set of -3/2 and +4. That's it. Alright, option 2 is the quadratic formula. Again, it's the second best way to solve quadratic. You just plug in a formula, a, b, and c, and simplify correctly. So the equation is -b plus or minus square root b squared minus 4ac all over 2a. The steps, again, make sure 0 is alone on one side. You might have to move things around, but that is standard form. You can label A, B, C, and plug into the formula. Make sure you're careful with the signs, and when you do b squared, always use parentheses. Then you simplify the part inside the square root sign, that b squared minus 4ac part. It should turn into a single number. Then you can square root that number. If you have a nice whole number, the square sign disappears, and you use that. For example, square root 9 turns to 3. Then separate both problems and simplify each. There should be a plus problem and a minus problem. That's why that plus and minus sign comes in. There are 2 special situations. If the number inside the square root is negative, that's where you use I. You get 2 imaginary answers. you actually don't have to split up your problem in that case, but you have to reduce. And the other situation is the square root number isn't nice. For example, square root 99. You can't square root 99, it's not a perfect number, but you can reduce it by doing the tree branch method. You do not have to split your answers again, but you have to reduce. One more thing is inside that number, inside the square root is very important. It's called the discriminant. It does not have the square root with it. It's just the b squared minus 4ac. That number tells you right away how many answers there are, whether it's 2 real, 1 real, or no real. And if it's no real, that means 2 imaginary. And it's because we're square rooting that number, that sign tells us how many and what type of solutions we have. If it's positive, you can always square root a positive number. We'll have 2 real solutions. If it's 0, you actually can square root 0, you get 1 real solution. But if it's negative, you can't square root of a negative number, so we get 0 real or 2 imaginary. Alright, so let's do a problem. Exact same problem. Step 1 is make sure standard form is equal to 0. Yes. Step 2 is label A, B, and C. So A is 4, B is negative 10, C is negative 24. Then you fill in the formula. So I'm going to write down the first time, but usually I don't write it down. X equals negative B plus or minus square root B squared minus 4AC all over 2A. So we fill it in carefully. The first thing says negative B. Negative B is saying as negative 1 times B. So negative 1 times negative 10 is positive 10. It just changed the sign of B. Plus or minus square root B squared. Make sure you use parentheses around B. So it's negative 10 squared minus 4 times A times C all over 2 times A. Next, I'm going to find the thing inside the square root. I'm going to find this right here. So if I find that, I then get this problem. So 10 plus or minus square root negative 10 squared, negative times negative 10 is positive 100. Then negative 4 times 4 is negative 16. Negative 16 times negative 24 is positive 384. Now you could use a calculator for this sometimes. All over 2 times 4 is 8. I'm still working inside the square root sign, so I can combine that. 100 plus 384 is 484. Alright, so right now I just found the discriminant is 484. Because it's positive, I know there's going to be 2 real solutions. So we have 2 real solutions because it is greater than 0. Alright, I'm now going to try to square root 484. I have a calculator for that. It says it is 22. So I get 10 plus or minus 22. The square root sign's gone. All over 8. Now you could just go ahead and split the problem right away, or you could reduce it. Reduce makes the number smaller. So I know 10, 22, and 8 are all even. I'm dividing all of them by 2, so I get 5 plus or minus 11 over 4. Now I'm going to split my 2 problems. We have 5 plus 11 over 4, and 5 minus 11 over 4. 5 plus 11 is 16, then I divide by 4. 5 minus 11 is negative 6, then I divide by 4. Those both reduce. 16 divided by 4 is 4. Negative 6 divided by 4 is negative 3 over 2. Those are the same answers we got earlier, and it's supposed to be. So I got 2 answers. My final answer here is x equals the set of negative 3 over 2 and positive 4. The order doesn't matter, though you should put the small number first. So longer than the first one, but it's very straightforward, step by step. The numbers get sometimes big inside the square root, but you might have a calculator for that. And usually you don't have to write the formula, so that's always how long it is. Never longer, but never shorter. Alright, the last method is called completing the square. It's a method that forces one side to become a perfect square, which then lets us square root it. It becomes square rootable. This method makes the problem have only one variable, which we can get by itself by using regular algebra. So you'll see we'll square root both sides later on. If you do choose this method, make sure you memorize all the steps and perform them correctly in order. So those 5 steps, you make A 1 by division if needed. You divide both sides with the same thing. Move C away from A and B. Then you add B over 2 squared to both sides. That's the most important step. But once you do that, the left side becomes factorable as x plus b over 2 squared. You could FOIL check. Then square both sides and solve. Don't forget the plus minus when square rooting a number. So here's the same problem. First, I'm going to make sure A is 1. I have to divide both sides by 4. So I'm dividing by 4. My new problem is x squared minus, I'll reduce that, 5 over 2x minus 6 equals 0. Second step is move c away from the left side, which I will add 6. So x squared minus 5 over 2x equals positive 6. And actually, let me do it like this. Alright, now I'm going to add b over 2 squared. I have to add some number right here to both sides. That makes the left side factorable or square rootable. Alright, so that's going to be, I'm doing the side here, b over 2 squared. So my b is negative 5 over 2 divided by 2. If you ever try to divide a fraction by something, you should change that second thing to fraction. So this is going to be, I'll do it down here, negative 5 over 2 divided by 2 over 1. When you have fraction divide fraction, you should change it to multiplication. That's the same thing as the first fraction multiplied by the second fraction flipped. So times 1/2, which then gets me negative 5 over 4. Alright, so this tells me it's going to be negative 5 over 4 squared. And because I see the square power outside, I can distribute in exponent inside, or I'd say negative 5 over 4 times negative 5 over 4. That's positive 25 over 16. That's this magic number that goes right here on both sides. When you add one side, you do both sides. When I do that, the left side is now factorable. I can change it into x and my b over 2. The thing in parentheses before I squared it was negative 5 over 4 minus 5 over 4 squared. So you could FOIL that, you'll get the left side. The right side, I have to do common denominator. 6 plus 25 over 16 plus 6 over 1. I'm going to times by 16 over 16. I'm going to get 96 over 16. I'll do like this. 96 over 16 plus 25 over 16. If I add those two together, I get 121 over 16. Alright, so this will be 121 over 16. Now there's only one x now. We had two x on the left side, the x squared term, the x term, which didn't combine, but now there's only a single x. I can do basic algebra. To get rid of square power, you're going to square root both sides. So square power squares cancel out. This is x minus 5 over 4 equals, and then I'm square root 121 over 16. If you square root a single fraction, you can square the top, which gets us 11, and the bottom, which gets us 4. Don't forget the plus or minus sign. Then I'm going to move this 5 over 4. So I get x equals positive 5 over 4. This 5 over 4 is positive, so it goes in front of the plus or minus sign, plus or minus 11 over 4. Because that's going to change. I create the two problems. So I have the first one's 5 over 4 plus 11 over 4. The second one is 5 over 4 minus 11 over 4. And that's going to be 16 over 4. This is going to be negative 6 over 4. Those both reduce. That's going to be positive 4. This is going to be negative 3 over 2. Got two answers again. So those two are my answers together. Set negative 3 over 2 and positive 4. So it's the longest, most complicated, but it does get you the same answers. I will do easier ones in class, but I tried to solve the same problem all three different ways, so you can compare. So that's completing the square. This quadratic formula is shorter, and then this is factoring the shortest out of all three. All right, the last slide is this. Some fun facts. If the discriminant is a perfect square, so square rule, that means the problem is factorable, in case you're curious to checking. If the discriminant is negative or non-perfect square, then that problem is not factorable. So you cannot factor it. You have to either use quadratic formula, which I recommend, or completing the square. And if a problem asks for exact solutions to a quadratic, that's a big hint that that isn't factorable, and you should do quadratic formula. All right, so I say, given the exact answer to this equation, you probably cannot factor that, do quadratic formula. And that should be it. Hope you enjoyed the video. Make sure you ask any questions in class. See you soon. Thanks again for watching. All right, bye.